Welcome to RIAPS Tutorial 2, Messaging and Publish Subscribe. This video builds upon the application from Episode 1 and is intended to introduce the Publish Subscribe messaging pattern and how to use it in your RIAPS applications. We will cover message topics, the properties of the Publish Subscribe pattern, and demonstrate Publish Subscribe by adding it to the PMU application from Episode 1. Distributed applications often use message passing to communicate and to trigger other components. An application may have many different types of messages, so it's useful to make sure components only send and receive the types of messages they care about. To do this, we define message topics. A topic is a logical medium that ports use to communicate. It allows the programmer to send messages to all other components connected to said topic, without worrying about creating and managing network connections to individual devices. For example, a PMU sensor running RIAPS might send its measurements as messages sent to a topic called PMU data. RIAPS will make sure that components listening on the PMU data topic get the message, freeing the programmer from having to manage network connections. The first message pattern we will introduce is called Publish Subscribe, or Pub Sub. Publish reports connect to a topic and send messages, which are received by any subscribe reports that are currently subscribed to that topic. Publishers and subscribers can come and go. Subscribers joining late will not receive any previous messages. Publish Subscribe is a very scalable messaging pattern, supporting many publishers and subscribers on the same topic. Let's add Publish Subscribe to our RIAPS application from Episode 1. Let's open the Smart Grid project and reopen our model file. Right now we have just a single actor, the PMU, printing data to the system log. Let's create a new actor to simulate a data logger that receives the PMU measurements and writes them to disk. Let's call it Data Logger. Our data logger needs a component to receive the measurements, so let's call it Phase Data Listener. We need communication between our PMU and data logger, so let's declare a message topic called PMU data. All messages are declared at the top of the model file with the keyword message and the topic name ending with a semicolon. To send and receive messages on the PMU data topic, let's create a Publish Subscribe connection between our PMU sampler and the Phase Data Listener. Add a publish port to the PMU sampler using the keyword pub followed by the port name. To connect it to a topic, follow the port name with a colon and the topic name. Our PMU sampler can now send messages to the PMU data topic. For our Phase Data Listener to receive those messages, we need to give it a subscribe port connected to the same topic. Start with the keyword sub, give the port a name, and then tell it to subscribe to our PMU data topic with a pattern like the above. We have now created a Publish Subscribe message pattern. We need to modify our component code, so use the RIAPS Gen tool like before, right-clicking on the .riaps file, finding RIAPS Tools, and clicking Generate Code. Open the PMU sampler and add a call to the publish port. We always add code between the RIAPS tagged comments so that a future code generation keeps what we have written before. Next, refresh the project and open the generated Phase Data Listener component. We can see that an on-sub port handler has been generated for us. This handler will run anytime a message published on the PMU data topic is received. For now, we'll just receive the message from the port and log it. We've updated our component code and created a new actor, so we need to update our deployment file to tell RIAPS where to launch the data logger actor. I have a second RIAPS node on the same network as the first, so I'm going to add a new line to my deployment file telling RIAPS to launch the data logger there. It's time to deploy our application. In the RIAPS control GUI, I point it to the application code, select the model and deployment files, deploy, and launch the application. In the first episode, we used the default component logger, which just writes to the RIAPS Deployment Services system log. This time, I have actor-level logging turned on. Actor-level logging creates a log file in the folder that is automatically created on each RIAPS node. While the app is running, superuser privileges are necessary to view the contents of a deployed application folder. To learn how to enable actor-level logging, review the logging documentation linked in the description. On the right, I'll tail the two logs that were created by the components on the remote nodes. The top window shows the PMU sampler providing data, and the bottom shows that the data logger is successfully receiving that data, all thanks to our pub sub messaging. Later videos will introduce more messaging patterns, device components, fault tolerance, and more.